Okay, so let's calculate the integral from 0 to 1 and the integral from x squared to x of 1 plus xy dx dy dx. And we already drew the region we're integrating over. I would definitely recommend that you take this step. For one thing, it allows me to give you a lot of partial credit for doing something that's not super hard. For another thing, if you dork it up, it lets me keep track of why you dorked it up. Okay? For a third thing, it lets you check the answer in the end, right? If you keep this and the volume or the density interpretation in your head, once you're done, you can say, is that a reasonable number? Right? Like, how big is that area? Well, this thing's definitely smaller than a half, right? This function's definitely bigger than 1, right? So if I get a number that's smaller than a half for the answer, I know I've dorked it. Cool? All right. So how do you actually execute this? What do you do? Okay, so you want to integrate d which? dy first.
So the x is going to be a constant.
Okay, so I'm treating x as though it's constant. I'm just going to leave the integral from 0 to 1, right? And I'm going to leave the dx. And what do you get on the inside?
Y plus xy squared divided by 2.
Y plus xy squared over 2?
Evaluated from x squared to x.
Perfect. Evaluated from x squared to x. Okay, so we get the integral from 0 to 1 of
minus x squared minus x to the 5th over 2.
Okay, so I got x plus x cubed over 2. Subtract, and you guys lost me.
X squared
X squared.
minus x.
You're just distributing already.
Yeah, Donald's already distributing. So I put a parenthesis.
It'd be plus
Oh, then
X to the fourth.
x to the 5th actually.
Yeah, it's fifth.
How many x's?
X squared squared.
Oh my god.
X
Okay, so I'm putting
Times
x
x.
squared in for the y's, right? So I've got an x and then an x squared
squared.
squared. And then I don't have to remember whether you add or multiply exponents in this case, right? It's 2 plus 2 and 2 times 2 are the same thing. Okay, and then I've got d. Yeah, make sure you don't lose that thing. It's pretty easy, especially once you're doing 3 variable, to lose that last trailing guy. Keep tagging them along. If you write a squiggle at one end, you better write a d something at the other. Okay, so all told out of this, I got what? I got the integral from 0 to 1 of x plus
X cubed over 2 minus x squared minus x to the 5th over 2 dx.
perfect. All right, then what do I do with this?
Integrate.
Integrate and then evaluate, right? So I'm going to get x squared
Over 2.
over 2
Mhm.
plus
X to the 4th over 6.
x to the 4th over
Over
8.
8. I recommend that you write the steps down. Right, so if I was doing this, I would write x to the 4th over 2 times 4. And then for this next one, I would write minus
Minus x cubed over 3.
x cubed over 3. And then for the last piece, I'm going to write
Yeah.
minus x to the 6th over 2 times 6.
Okay. All evaluated from 0 to 1.
Evaluated from 0 to 1,
Which
which
is
is in the end
1/2
This one eight.
a half plus an eighth
minus a third.
minus a third minus a 12th
Cool, that's the answer.
Yay, no arithmetic.
equals number. Perfect.
Can we do that on the test?
Yeah.
Yay!
Yeah, absolutely. Don't convert it to decimal.
And it's less than a half.
Yeah, you might convert to decimals if you want to check your answer, but don't convert it to decimals and circle it. Just circle it as a fraction. Cool?
Yeah.
Questions, things? Ballpark right? Yeah, how could I, like, just ballparking what my number is? An eighth and a 12th are both small, so they cancel. So I've got a half minus a third.
There's less than
Definitely smaller. A third smaller than a half, right? So I definitely got something positive,
yeah.
But a third is
and it's
greater
relatively little, so it's definitely underneath my threshold of a half.
But a third is greater than an eighth, so. Oh, yeah, so
Yeah,
yeah.
but
that you
I already
you-
canceled the eighth with the 12th. Those canceled, right?
You have to get to 72.
Yeah, so just ballpark, right? This is really a rough ballpark.
Yeah.
I'd say this is like
It's not right, but it's good enough.
X minus X cubed.
about a
X squared,
sixth.
right?
It's good enough for government
Sure.
work.
Good ballpark? Not really. Is it under the threshold I stated at the beginning? Yeah, totally. Is that good enough for a check? It depends on your level of precision. Cool?